Hello everyone and welcome to APNIIC 50. My name is Sienna Perry and I will be the MC for this session. I will shortly hand over to APNIC EC Chair, Mr. Garib Obadiah, to start the official proceedings, but while I have your attention, I'm going to do a little bit of housekeeping. As with all APNIC conferences, please be mindful of the code of conduct. It's published on the APNIC 50 website and shortly in the Q&A box for your reference. If you have any questions about the event itself, using Zoom or any other questions not related to the presentations, please use the Zoom chat and APNIC staff will help. More help is available on the APNIC 50 website. After Garib's welcome, we have the pleasure of brief remarks from Mr. Hakim, who is the Internet Service Provider Association of Bangladesh President, and APNIC DG, Paul Wilson. Immediately following these gentlemen, we have Philip Grasso, Global Head of Network Architecture and Engineering at Google, delivering his keynote. At the end of the keynote, we have time for questions from the audience. I'll give you some more detail about the protocols about asking questions later on. And finally, we may not all be in one room for this conference, but we certainly are still all in it together. To celebrate this, we would love for you to share a photo of you participating in APNIC 50 on Facebook and Twitter and use the hashtag APNIC 50. I'll now hand over to APNIC EC Chair, Mr. Garib Obadiah. Thank you.
Thank you, Sienna. Hello, everyone. Good morning, good afternoon, or good evening, or even good night, wherever you are watching this from, wherever you are participating from within the APNIC region or somewhere else in the world. This is the first fully virtual APNIC conference ever held. Of course, this is due to COVID-19 and the resulting situation where we can't really travel and meet face to face. We have done a lot of virtual interactions in the past, but we are kind of disappointed in not being there in Dhaka, but also kind of excited about the fully virtual online APNIC conference. This is kind of an understatement of the fact that we aren't there. It is a big impact. Not only for the conference, but also for our life, our health, family, work. I think we are all coping with it, especially in our community that works in critical infrastructure, providing access to everyone else affected by this. This is probably a big, enormous burden we have right now. So this conference was no different. I think already in Melbourne, I think we're starting to see travel impact, but we just got through it, and then the situation started getting really bad. Just after the APNIC 49, the ICANN meeting, which was the week after, got converted to a virtual one. And since then, we've seen a lot of events getting going virtual or getting canceled outright. Given that situation and given the inability of our people to travel, we are really disappointed that we can't come to Dhaka this year and move this whole event online. We have the president of ISP Association of Bangladesh, Mr. Hakim, today, right after me, to say a few words. But outright, I would like to thank our friends, our colleagues in the ISP Association Bangladesh, and Mr. Hakim and everybody else there in Dhaka for understanding. And the community there has been really supportive of us and helping us prepare to move online. And personally, I'm a bit disappointed because I always have loved going to Dhaka and be there and meet with the community there. But there is always a next time. Obviously, we've said we're disappointed not being in Dhaka, but we'll try our best to come back there as soon as situation gets better. We'll start looking at future events, and then we'll see when we can return to Dhaka at the earliest conference that can be possible in the region. Having said that, let's move on to the virtual participation bit. We've always allowed remote participation. When I started coming to APNIIC meetings, it was just a broadcast. In later years, we have had interactive participation at the conference, and in for the last few years, we have had pretty active online interaction at the events. Even I participated fully online about a year and a half ago when I could not make it to the conference. But then this is still a bit different. This is the first time we're doing completely online, virtually, and we'll just have to adjust to that. So as Sienna said early on, let's keep the courtesy. We're trying to learn new things, do new things, but our code of conduct still applies. Let's follow the rules of online interaction, be courteous, and help each other along the way. I'm pretty sure we'll have a bunch of technical problems during the week. So let's just learn from it and support the Secretariat in delivering this event during the week. Now on to good things. This year so far has been a big challenge. As I said, I think in Melbourne, we just escaped with a very, very fine line. But since then, or this year, it's been pretty good for APNIIC so far. I'll highlight on 3 different things. First one is the Apennic Foundation. When the foundation was started, we had set a goal that it would be self-sufficient in 5 to 10 years. And this year, as you'll hear during the week when the foundation provides an update, it's been pretty good. And we are going to achieve that self-sufficiency goal probably this year, if not in near future. This was made possible by a big, generous grant by Professor Jun Murai and the WIDE project. Through the formation of the APNIIC, the Asia Pacific Internet Development Trust, and the grant that was made to it. That was a big contributions from Professor Jun Murai and the WIDE community. And I'm really, really thankful to Professor Murai. Of course, over the years, he has helped APNIIC and become really part of our community and one of the leading lights in our region. And his contribution really helps us take the objectives of the foundation forward. Since we announced the trust back in Melbourne, it has made a lot of progress. You'll hear about it from Paul during the Secretariat report, during the AMM. And we've made a lot of progress in the sense that we see the foundation being self-sufficient with the support of the trust in near future. So once again, I'd like to thank, on behalf of our community, the APNIIC community, and the entire Asia Pacific Internet region, and the APNIIC EC, to Professor Murai for initiating this very exciting development. And we reiterate our commitment, APNIIC, Secretariat and the EC commitment to working together for the development of Internet in the entire region. I think this is a very exciting development, and we can only see good things come out of it in near future. The second news that I would like to share or talk about is the APNIC survey. That is another one of the APNIC EC's role. Is we conduct the survey every 2 years. And most of you know about it. It is conducted as part of our regular planning process. It gathers feedback from our community and stakeholders about APNIIC's performance, priorities, and future activities. I would first of all like to thank all of you who participated in it. We had a big record response this time. we had a total of 1,624 responses. That is 31% more than what we had the previous survey in 2018. On top of it, we also had the survey available in 16 languages this year, and 35% of the respondents choose to complete the survey in a language other than English. So we are really excited about that. In fact, in case of Bangladesh, we had a lot of responses, and about half of those were in Bangla. So we're really excited that we're able to generate more feedback with the addition of the additional translated survey to our members. The full result is actually now available on the APNIIC website, and it will be presented during the AMM. But you can go start looking through the report and see what the members have told us and what the stakeholders have told us about APNIIC there. But I'll share a few few things, a summary of it. In the past surveys, compared to the past surveys, we've seen a rise in endorsement of APNIIC from members and the community, and it has continued to grow. In 2016, the number of responders who spoke highly of APNIIC was 41%. In 2018, that increased to 56%. And now in this latest survey, that has increased to 66% of the respondents, which means that, the Secretariat, the community, and the EC is probably doing something right. And we continue to strive to follow the feedback from our members. To witness this continuing upward trend is very important. And this metric is also very important and pleasing for the EC, as it is a strong indicator that both the long-term strategy and the annual operational activity of APNIIC is in line with what our members want us to do. Of course, despite all the positive feedback that we receive in the survey and through our interaction with our members, we are not going to rest. We, the EC and the Secretariat, will continue to do better and improve and maintain the highest standard that we can achieve and that our members have come to expect from us. There is a lot of excellent feedback from our members throughout the survey. There is a lot of open responses. And once we have a time to digest through that, we'll issue a EC statement on that in the following months. I encourage you to go look at the report and attend the discussion on the AMM on Thursday during the meeting. So that was the survey. The other item that I look forward to the AMM is how we present our report back to our community. In Apricot in Melbourne, we shared our 4-year strategy going forward. And as we have said in the past, every 4 years, the EC gets together with the Secretariat and we run a bottoms-up long-term strategy for APNIIC, including the inputs from the survey. So last February in Apricot, we presented the 4-year plan. It's on the website as well. This will be the first meeting where we are going to start reporting based on the high-level pillars identified in that 4-year strategic plan. So please take a look. This will be a new exciting way to look at the activities of APNIIC and to see how we are tracking against the 4-year strategy. So that is a big change in how we've reported in the past as well. And hopefully this is more exciting to our members to actually see what we are doing relates to how it impacts your membership or your relationship with APNIIC. And of course, those are the 3 things. We always invite feedback from our members. You can always talk to us. You can email us. If you have My APNIIC, you can go online and provide feedback to the EC directly. And we are always open to the feedback. Of course, this year is all online, so you can't give in-person feedback. But as I said, there is multiple ways that we can always receive feedback and interact. And we welcome that from our members. Having said all of these things, I think I hopefully the situation will get better. We can still get back and get together in near future. I realize that a lot of the conferences, the events, the forums we participate in have all been virtualized or have been canceled. But we are hopeful that it'll come back. And despite the lack of face-to-face interaction that we look forward to and cherish in these meetings, we'll continue to do the good work that we as a community undertake towards the stability of the internet. Continue to participate and interact using the same technology that we create and maintain on the internet. So this is, a big reflective moment for us as well in using these technologies that we have long supported and worked on. I won't take any more time. Thanks again. I hope we all enjoy the next 3 days, especially all the participants. Hopefully we'll learn to use the online technologies for the event better. And having said that, I now declare the APNIC 50 officially open. Thank you very much. Back to you, Sienna.
Thank you so much, Garib. I now have the honour to invite Mr. Hakim, President of the Internet Service Providers Association of Bangladesh, to the microphone.
Good morning to you all from Bangladesh. Dear Honorable Speaker, colleagues, ladies and gentlemen. On behalf of ISP Association of Bangladesh, I express my gratitude to Apnic for giving me the opportunity to welcome all delegates, speakers, and participants in the Apnic 50 conference. I believe it is a historical moment for all of us. It is the 50th conference in the long journey of Apnic. It is held online for the very first time in view of COVID-19 pandemic situation around the world. It is also a sad moment for me and the IT enthusiasts of Bangladesh because it is the second time that we missed to host the conference in our country. I hope after the pandemic gets over, Apnic will consider Bangladesh as host with the top priority. People are very eagerly waiting for the opportunity to express their true Bengali hospitality. Bangladesh has seen tremendous growth in internet over the last decade. However, the community is facing many challenges, starting from network design, poor infrastructure, cyber attacks, to get IPv4 crisis, and lack of policies. I hope through this conference, experts and professionals from around the world will come together to share practical knowledge, technology, and open debate on policy that best work for individual operators and the community at large. I hope that in spite of COVID-19, all participants will acquire new skill and knowledge from Apnic 50 online conference, and I would encourage all participants to take active part in the interesting discussion to be held to conclude certain policies for the region. Lastly, I would like to congratulate Mr. Shumon Ahmed Sabir, Achi, and Kam on their election to the Apnic EC. And again, I am very much thankful to Apnic for their diligent work and arranging this event. Special thanks to a sponsor for their great support to make this event possible. I wish all delegates and participants a fruitful conference and enjoyable. Thank you. Thank you very much to all.
Thank you very much, Mr. Hakim. May I now ask Apnic DJ Paul Wilson to take the virtual stage.
Right now, I can't start my video. Start video. Hello, everyone. Thank you very much for joining this event, APNIC 50, the first fully online APNIC conference. It's disappointing that we couldn't be in Bangladesh this week, but as Hakim and Garib said, this event will definitely come to Dhaka as soon as that's possible. The reason we're here online, of course, is the COVID-19 pandemic, which has affected all of us. I really hope that everyone here is taking care and staying safe and well, you and your families as well. But there's one thing I think we can all be really proud of right now and even celebrate, and that's how the internet has performed during these times. In so many parts of the world, it's been in demand like never before. As so many people work and study from home, businesses and governments have relied on it, actually, and have assumed that it'll just work. I think, in fact, the internet's been completely taken for granted, actually. And yet I've also heard it described as the glue that's holding together societies and economies through this whole period like nothing else can. That without the internet, the impacts of COVID-19 would be so much worse. So the internet really has delivered. It's delivered like never before, even though we never planned for this or practiced actually for this particular scenario. And we probably should have practiced, because it's always been a possibility, this kind of global health emergency. And there've been some pretty serious impacts online because of it. There've been big changes in internet traffic patterns and types of traffic. We heard about this at APNIIC, at the Asia Pacific Internet Exchange meeting yesterday, with reports of increased traffic volumes of up to 30% at some exchange points. So it's pretty clear why, because of what we're all doing now, which is using real-time video predominantly. And that's a service that requires real-time, end-to-end, high-speed, symmetrical bandwidth. It's not something that you cache in your local CDN. There's been an increase in IPv6 traffic as well, because it seems that homes are better served than businesses these days with IPv6. But the thing is, even with these unexpected or unplanned changes, there haven't been widespread problems or outages of any kind that we're hearing about. And that's also, that's not only a great relief, but I think it also reflects a really huge achievement by the internet community. It's not to say actually that work wasn't needed, because it was, and I'm sure everyone's been really busy, but that's also a feature of the internet, that even with a widespread stress like this, we all adapt in a decentralized way. We adapt according to local demands, and we're all able to do what we need to do when that's needed in our own judgment. So the original model of the internet is about that decentralized management, but it's also about global symmetrical end-to-end connectivity. Some people, like Jeff, have observed that these features of the internet, these original features, are dying out, or they're threatened by modern industry trends like CDNs, like content distribution networks. But COVID has actually shown us, I think, how much we rely on the internet, the original global end-to-end internet, that is, and how much we rely on broadband as well in both directions, upwards and downwards from the customer's perspective. So I think we'll hear a lot more about this into the future after the pandemic, in terms of how the internet did perform, how it did what we asked of it during this period. And there were lessons, of course, but it's really a great success story, I think, which validates the current model of internet technology, of organization, and also of governance of the internet. We'll also be hearing more this week, of course, with keynotes from Google and Akamai, and technical sessions today and tomorrow, where COVID effects will certainly feature quite extensively. That's not all for this week, of course. Internet security this week will also be a big focus, as it always is these days at APNIC conferences. And we have a full security track tomorrow with FIRST. And a big topic for the internet community, for the APNIC community these days, is security of the routing system, and how we can improve it by, particularly by deploying RPKI and route origin validation using ROAs. You might know that we have a new special interest group meeting about this, the routing security SIG, and that'll be happening tomorrow afternoon as well. There's a lot more. And I do hope that APNIC members in particular will join the members meeting on Thursday for all the latest updates about activities and developments at APNIC, which Gaurav mentioned. That meeting, of course, is also open to anyone who's interested, not just APNIC members. It's really great to see that we've got more than 1,000 people registered this week for APNIC's first fully online event. I really hope that every one of you will enjoy this week and take part in as many of the sessions as you can. Don't forget also, we've got a social space open over these 3 days And that's a place where we can all chat with other attendees, chat with speakers, and it'll be open for the social event later on towards the end of the day. So please go and check that out between the sessions, and I hope to see you in there as well. With that, thanks again very much for being here. Please do stay safe and do enjoy Apnic 50 this week. Thanks a lot, and back to you, Sian.
Thank you so much, Paul. This concludes the official proceedings. I will shortly invite Philip Grasso from Google to present on the self-driving network. As I mentioned earlier, we will have some time for questions at the end of Philip's keynote. We have two ways to ask a question or share a comment. You can either use the raise hand function in Zoom and you will join the queue for voice, or use the Q&A button on Zoom for text, and I will read out your comments or questions. Philip, the stage is yours.
Thank you, Sienna. Hello, everyone. Good day. Given all the different time zones, I think that's the most appropriate answer. Hopefully everyone can hear me. I just want to get a little bit of admin sorted out. Is audio working? Yes, I'm going to make the assumption everything's okay. And can everyone see my presentation? Excellent. So thank you, everyone. Okay, so just getting started. I was invited to provide a talk on self-driving networks, and part of the talk was basically to go through what is Google doing as a leader in the industry and what's happening in the market, and to share a little bit to everyone on the way we're thinking about problems, how we've gone and solved it, and some of the things ahead, to kind of just make sure that everyone has an opportunity to see what goes through our minds when we're thinking about this. So this is an extension of the talk Bakash Bakali did in February at NANOG, and this goes into a little bit more of the reasons why we're doing self-driving networks and the path there. The journey and what we're aiming to do is get to a point where we want to move from networking 1.0, and I define what that is, to networking 3.0. This is part of the journey. We're on the way there ourselves. There are different facets that we're working through, and we want to kind of just go through that with everyone. So the first thing I want to kind of go through is like the why. Like, why should anyone care? Why should we be doing this? Why would you want to do self-driving networks and so forth? And I've given a few talks in the past, and not everyone maybe has had an opportunity to that. So I'm just going to summarize the key content associated with the why. Why did we move to zero-touch networking? Why did we kind of go through these phases and so forth? And it comes down to the first one, which is, unfortunately, being human means that we also make errors. And what we discovered when we were doing work, operating one of the largest networks in the world, was that when we actually had a change freeze, our outages went down, and it was directly tied to work. So that seems pretty obvious. What we wanted to do was we wanted to continue to be able to scale up working, but it wouldn't meet our outage windows, and it wouldn't meet the service levels that we needed to do. So we needed to kind of do things better, and we wanted to fix the problems associated with that. What we discovered was that we wanted to kind of audit it and then make sure that it was right. But then we discovered, oh no, after we audited the problems, that only told us after something broke, right? And so the problem with auditing is it's too late. Then we got told, oh, well, maybe we should fix it before it happens. And so then we went through some various stages of automation and so forth. And as we went along, we discovered an important message, which was that we really needed to take humans out of the picture. And the reason for that was because humans make errors, right? Like, it's like driving down a street. People are tired. Emotional state actually played into effect. Not everyone had all the information to make changes correctly. How many times as operators and as people that run and manage networks have you seen or challenged when you bring someone new on, they needed to understand what happens in your network today? That continues to be a problem and will continue to be a problem in most environments. So getting humans and perfecting operations was a big deal. Next thing is we need to be able to scale up. We were continuing to grow, and I won't try to say that everyone needs to grow at Google scale, and maybe other people don't, but every network has some growth or change factors that need to apply to it. At Google, we had to scale up really, really quickly and continue to scale up really, really rapidly. So when we went through this rapid expansion, we were introducing, because of the first point, a lot of problems in the network. As we kind of grew up and as we kind of put more things in, we found that it just was really tricky to be able to scale up. Then we had to do other things like get cost efficiency to scale and introduce new hardware. LCM, which is lifecycle management associated with hardware, we had to replace, and that just continued to bear on us, and we had to do that on a non-stop basis. So scaling was a big deal, and I think most people kind of have this issue, but like that changed the game for us quite dramatically. And we had to do effectively every year twice as much work, 3 times, 4 times, right? And then eventually we're doing magnitude more work than we did before. And the only way to be able to do that is through software. So we had to kind of keep on hitting that problem. The next one is that we kept getting challenged on growth. And this is kind of like a big word, and I kind of pronounce it wrong sometimes. So it's asymptotic costs or growth. And what this represents is a curve that basically is approaching zero but never gets there. And this is the efficiency factor. What we want to be able to do is drive towards the best efficiency we can. If you ever talk to your CFOs, this is something that they deeply care about. And as network operators, we care about this as well. We want to be able to deliver our network for the least amount possible. And one of our largest costs was humans. Not that that's a bad thing. However, in order to be able to scale up, you don't necessarily want to be able to scale up your human-driven infrastructure as fast as you scale up the network. So you want to be able to continue to grow that exponentially or significantly better, and then continue to drive your costs or your labor associated with running the network down to a minimal point, right? And what we've discovered through this process is that we continue to need people, and actually more people. However, what we could do is we could deliver more bits with the number of people we had. And then finally, we need to kind of meet our service levels. We need to make sure that we're managing operations and we're enabling operations to be better, and doing that at scale, minimizing human error and doing it cheap is a big deal. And that's where we kind of went through and said, okay, these are the reasons why we had to do self-driving network. And I can tell you that most of these things we fumbled on, right? We learned as we grew organically. And then going back, we said, okay, these are the problems we're going to go solve. So we're not alone in this. In other industries, like for example, the car industry, they're trying to do automation. They're trying to do self-driving. Self-driving is a term we actually borrowed from Waymo, about being able to, drive cars automatically down the street and save lives as a point of that. So I've kind of put a plug in here in terms of Waymo and their kind of tagline. This comes from their website, which is that we're building the world's most experienced driver. And I kind of was a little bit cheeky and said, okay, well, maybe we're going to try to build the world's most experienced network engineer through a software system. So this is like our objective, being able to run the networks automatically so we can pretty much sit back and relax. Now, that never really happens, but that's the dream, right? So we want to be able to kind of let the network run itself, not have to worry when links fail and people are really on us, and imagine that actually fixes itself and so forth. So I'm going to kind of go into a little bit more. But in order to do that, I want to kind of talk about the networking 1.0, 2.0, and 3.0, and just some of the concepts associated with that. Okay. All right, so firstly, networking 1.0. This is something that you should all be pretty familiar with. It's human orientated, right? Pretty straightforward. humans are the result to get the work done. You want to be able to connection led, right? That's associated with circuit switched, or it mattered about like whether you're running MPLS networks or like DWDM networks, packet switch, VPNs, and so forth. So that's just, it's driven by the connection type that you bought and you deployed and you utilized and so forth. Sorry, I need to make sure my earphone's working. Then secondly, scaling up was a factor of having God boxes, buying the bigger router from the vendors, right? And then just continuing to buy infrastructure as much as you can, and so forth. Arguably, it was closed. Vendor implementations were closed. The options were you had to buy the equipment that was made available to you, and you didn't have a lot of choice in order to achieve certain outcomes. So vendors mattered quite a lot, and whilst there was a level of interoperability, it wasn't guaranteed. So standards did not guarantee interoperability, unfortunately. Mostly it kind of worked, and vendors managed to work around it, especially the second or third vendor that came in generally just made good with whoever the primary vendor or whoever had the primary market share was. So moving through that, we moved into the networking 2.0, and this is where automation kind of really came in. Software-defined networking came in. We talked about things like being able to scale out, so using fabrics instead of chassis, thinking about the network as cattle and not pets, where you had to tenderly care for your pet, where you had to treat the network devices more on a bulk perspective, like that's the industrialized hard networking and hardware and so forth. And then fault tolerance systems were kind of put into software, and then you ran networks by large numbers rather than having very small number of links, and being able to kind of mesh your networks out a little bit more, having a lot more resiliency by kind of scaling out and building fabrics effectively. Within this, like if you think about one thing about scaling out, if you have an environment where you have a super reliable switch, say it's got a MBTF of 30 years, if you build a fabric of 1,000 of those, you'll have one fail a week, right? If you're building, if you're using super reliable pluggable optics, I think the MBTF 50 years thereabouts. And if you plug around about 20 or 30 of those into the switches that you just had, you're having one of those fail a week. That starts to add up, right, and stack up quite a lot. So you have to be able to build infrastructure that supports that. And then what we're kind of working out is the internet fabric. It isn't 5 nines of availability. It's something much worse, right? So what we've kind of gone is we've gone and used software to help redefine how we do reliability and how to work around those failures and have more intelligence in that. And that's where we kind of move to some of the aspects associated with software-defined networking, right? Software helps make the network more reliable. And then you have to build it on things like common software. Then you can do things like put abstracted APIs and very well-defined data models. Those data models help you do more intelligent things on the network, and then do things like, for example, automation, right? So that automation helps make the software more reliable, allows you to kind of do things like trade-off scale, reliability, and efficiency. And then it gives you the actual ability to achieve all three rather than two, right? Typically, getting one is normally easy. Getting two is really tricky, and getting three is almost impossible. But with software, you get that balance of scale, reliability, and efficiency. And then you can actually do other trade-offs. Cost, right? Efficiency. Scale out allows us to kind of do things like in terms of capital make new decisions associated with how you manage your OpEx and so forth. And then going through data led. So where is your data these days? It may be in a data center. These days, it's actually moving to the internet. If you look at where traffic volumes and flows are, most industries, most businesses and so forth are either probably moving to cloud, or a lot of the existing content comes from the internet as a whole. So where the source of sinks of traffic are is also changing. So this is where, things are more internet orientated and cloud based and so forth. So that's kind of just defining where networking 2.0 is. Then we're going to move into something a little bit more futuristic, which is networking 3.0. And I'm going to kind of go into these in a little bit more detail in the next slide. But effectively, application led, disaggregated, open, self-driving. Okay, so let's go into a little bit more detail associated with these. So in terms of application-led, it means that things can be a bit more fungible. We can define reliability better, right? We can do security and we can create ubiquity. So let's talk about fungibility. You can do high bandwidth, predictable things like low latency decisions. You can choose where you put your storage, whether it be local or remote or through compute or so forth, or cloud-based. Reliability enables you to have different factors in terms of fault tolerance. You can do things like local or remote replication. You can do a whole bunch of different things in that, because your application has a whole bunch of intelligence in it that is less orientated to this is all you get in the traditional world, which was connection led, and hey, you get an MPLS network, you have to use that. Now applications can interact with the network in a more intelligent way, or is taking advantage of the networking features in a more intelligent way to make better decisions. And then security, but making all of the data associated with the network available to higher layer security means that you can actually do defense in depth, you can do better containment, you can do better threat monitoring, and then you can also put responses in a more intelligent way. And obviously ubiquity in terms of access. So kind of moving through that, we go through disaggregation. That kind of relies on having a disaggregated forwarding plane. You're able to do a whole bunch of things like build microservices around networking devices, cloud function, and NFV function. Like, I'll give you an example. Where would you put your firewall? Now, in the past, firewall would be a physical device. Now it's a virtual device. Maybe it's actually done in the cloud. So in this new world, where is the network boundaries that you had that existed before? It's a different world, right? And that's where disaggregation is. That's where we should be able to run our implementation on multiple environments and then have it provided through an abstraction layer through software and data models, right? And then open. Won't go through too much, but like there's a whole bunch of things: OpenFlow, P4, SAI, GNMI, GNOI. There's a whole bunch of systems and open standards and open config that's kind of existing, and the market's moving towards to try to achieve that level of true openness. And frankly, we're probably not there yet, but we're on the way there. So and then going further, we kind of go down to the self-driving, and that's where I'm going to cover a little bit more later, but effectively that's where we're able to kind of do things through the system itself. And I actually go through a roadmap of what those steps look like, and then what are the stages of self-driving, and then what do you achieve. In self-driving, what we want to be able to do is just take humans out so then we can solve the problems that we described, right? Removing human error, enabling asymptotic cost and efficiencies, having the best operating environment improvements and being able to scale out, right? And those are the outcomes of self-driving, but then there's certain things that we need to do in order to get there. That includes moving to zero-touch networking and being able to realize that higher level objective. So in networking 3.0 or self-driving networks, we talk about like the OSI layer in terms of that it's not necessary in terms of where that is at the moment. So the traditional OSI layer would be considered not as relevant as it was previously. Applications are a lot more intelligent and can make decisions, and that's normal for us now. Like in self-driving networks or self-driving cars, there's a whole bunch of self-reinforcing learning models and machine learning models and AI application that continuously improves the cars and safety and how it learns. The same also applies to networking, and I have a few examples of that. One of which is, for example, and to this community, let's have a consideration: IP address management. If I ask you this question, do you have IP addresses in your network? Let's say IPv4 addresses because they're a little bit sensitive. Do you have IPv4 addresses in the network today that you're probably not making the best use of, but it's just too hard to fix? I can tell you we have that problem, right? We've got a problem where we've run out of IPv4 addresses for a whole bunch of our internal applications because the internal network's so big, right? Is it because we've run out, or is it because maybe we're not utilizing the address space as efficiently as possible? So now in a self-driving network, we would analyze our address pools, look at how much it's been used, look at the devices that are attached to segments, what right size, and build a machine learning model to kind of right size what that right size is. Then apply the APIs to go and resize it automatically. So update the model, update intent, update the network. Now, would you trust the machine to resize your address space? That's what the type of problems that we're starting to engage and try to solve automatically through self-driving networks today. But you need to have a bunch of things in order to do that, right? And I'm going to go through that next. And something a little bit more controversial is Sre Operates the Infrastructure. And this is where some people have some form of disagreements or what that is. Effectively, what we're saying is that instead of humans running the network, humans run the machines that run the network. That's what we want to achieve going forward, because that allows us to achieve the scale. Now, S3s, network engineers, the function's the same. We need to just be managing the machines that do that automatically for us. And then we need to apply our knowledge, know-how, troubleshooting, and so forth. And I guarantee you, even in a very highly automated network, stuff breaks. Vendors change things. Software engineers change things. Network engineers want to achieve different things. There's always going to be a place for a human. The objective here is to actually just scale up. Okay. So I want to kind of go through a little bit more detail about what intent-based networking is, because this is a precursor and something that's pretty much needed in order to achieve some of the loftier goals that we're talking about. So over here we have a intent object, and that basically is a like detail associated with what the network is and so forth. And that gets generated into a network model. Sometimes we call it internally model-based networking, or and the industries use intent, and intent was something that myself and some other people in Sydney actually dreamed up while we were talking about how do we kind of make sure that we fix the problems that we were doing earlier on. And luckily, this actually is being coined in the rest of the industry, which is that you're driving the network from what you're saying is correct, rather than what you're looking at the network. Now, if you have to look at the network to know, is that right? Then what you have is you have a situation where what you say the network should look like and what the network looks like is not necessarily the same thing. And that's bad, because that's how you get documentation issues and you can't apply automation and the other things. So what we've done is we've taken the intent and we've mashed that and turned that into a network model. The important thing about the network model is it is a software representation of what the network looks like. We've released this out to the public. It's called MALT, and internally we call it UNM, which is Unified Network Model. So we take all of our intent, we put it into a data representation and software manipulable, software readable format of the network that says this is what the network should look like. And then going out of that abstraction allows us to go and orchestrate configuration on the network. So we will generate configuration as we need. So now we have a network model. Say we want to produce a vendor 1 implementation, we'll do that, and we'll say, and the configuration is only a rendering of the network model. All we do is say, oh, just give me what this would look like in vendor A. Now we want vendor B. We can do a software representation of vendor B. Wow, imagine that. You can now swap out a vendor with almost no work. And what I mean by almost no work, for us, we just define it through a workflow in the network model somewhere, and we say, hey, this device should be this vendor for whatever reason, and that will be vendor A. Now, if this is now vendor B, then we'll actually go through and recompile or re-render the configuration in the other format, or even better, we'll do it in OpenConfig, right? And then hopefully the vendor can accept that OpenConfig, but if they can't, no problem, we can actually generate it. That allows us to actually have price competitivity, because we're not locked into any one particular vendor anymore, and allows us to kind of change things on the fly. But that network model now also knows everything about other devices. So I'll give you an example, a BGP configuration. When you do a BGP configuration, you're not just changing BGP for one device. Normally that sits into a mesh, whether it be route reflectors or confederations or a wider network. You want to change that configuration. Now you have to change n number of other devices as well and make sure that that's been added. So in the network model, we would do all of those transactions in the model, show a representation of what the network should look like, and then push that out to the network appropriately, go through safety checks. So we have to constantly have a look and say, hey, before you do that action, this network is in a frozen state for some particular reason and so forth. And then when that comes out, then do goal seeking to be able to bring the network into harmony and ensure that that network is constantly built according to what is the specification on the network. And this applies to security policy, applies across the board. So then that way the network is always harmonized with what your documentation or effectively what your intent is. So moving to the last one, here's the journey that I kind of talked about, right? And in this journey, we go from human driven. That's where what you do is effectively, you want to add a network device, you want to manage one, you want to RMA something, you want to turn down a link. You go in and type CLI commands. If you're doing that, you're in stage 1. If you now have a workflow to describe what you need to do, and you can give it to someone that may not be the most senior engineer to do an action. Say you can give it to a contractor to do that work, and they may not have entire state of the work, but they have enough intellect and skills to be able to do the work. Then that will be workflow driven, and they can go and do work pretty much automatically within your work, and you can be able to give them something. Next up is event driven. That's where certain actions will be done automatically based on things. So say, for example, you're receiving a lot of interface errors on an interface. The software would come through and identify those areas and shut down that link automatically, or trigger a capacity upgrade once you hit your thresholds or your designated analytics model to say, hey, time to upgrade, and so forth. Then machine driven is basically where the machine will do those actions automatically. So that's where we kind of get to the ZTN iron. So ZTN is kind of like at stage 4, where you can do zero touch networking on most of the network, and those actions are done pretty much by the machine. You plug a device in, it turns itself on, brings itself into protocols, and now it works. It sees problems in the network, and you can get it to do actions. That doesn't mean you don't have humans, but you can actually do a lot of your functions just through software. We're about there, right, in a lot of our workflows, a lot of our processes. And then the last one is moving to that autonomous infrastructure, and that's the examples of things like IP address subnet, auto resizing, auto adding capacity onto the network, and so forth, and being able to analyze the existing capacity and then managing that. So that's where we are, where the journey is. We're not at 5 for everything. We have touches of 5 at Google. A lot of our work at the moment is sitting between 3 and 4. And it depends on the process and depends on the network and so forth. But we're evolving this as we go. And this is just to help kind of define where we are on the continuum of self-driving networks. And we're getting there. And we're pretty far ahead. So lastly, are you ready? Open for questions now.
Thank you so much, Philip. We are really pressed for time, but I can see we've already had one question. If you do have questions, please get them in very quickly. We will take the ones that we can fit in. We have one from Kapil Goyal. What is the business strategy for self-driving networks for the automotive industry?
That's a great one. We work with Waymo. That's a Google Alphabet subsidiary. And their telemetry and networking requirements is massive. They have effectively hard drives collecting telemetry every single day, and we're transporting that back to actually do cloud-based analysis and a lot of the ML and AI learning systems to kind of continue to develop that. So that's a really, really big deal. Now, when cars are doing all of these intelligent things, the connectivity layer is just continuing to grow, and the expectations associated with that is massive. And then even we're providing real-time intelligence back to the cars to say, hey, these other cars have seen this situation, it's been analyzed, you need to do something different. That's also a big deal at the moment. Any other questions?
You know what, Philip? I think we could probably continue talking forever. Or we do have one more, and I'm just going to say this is the last one. Does the 3.0 model make troubleshooting harder? What if something breaks, says AFTAB?
That is a fantastic question. So, yes and no. In the simple cases and the high transaction cases, the ones that you would have had a NOC or level 1, maybe level 2 person deal with, those ones are done a lot faster, and pretty much all of those almost disappear. With automation, you bring other problems. Some of those other problems is if you let the network do things itself, then you have to put controls in there. We've learned some things the hard way. For example, admission control. You don't want automation to do too many changes at once, and so there's a whole bunch of key principles that you have to apply to make sure that automation doesn't go rampant, because it can also destroy the network much faster if you don't put those safety checks in. And we've been spending probably most of our time designing things like safety checks, like those really obscure problems to say, oh, what happens if this happens? Those are the type of safety checks that we've been putting in the network, and some of them no human would ever go and say, I'm going to go check, because that's just crazy. But when it's software, those cycles are pretty much free. So we're like, yes, let's go do that. Let's put that check in, because that may happen. And we've actually discovered that in a really small fraction of the time it does happen. For a human to execute that, it's not worth it. But for a machine to do it, it is. But going back to the key point of the question, yeah, it does introduce some other skill sets that you need to do, which is especially understanding software systems, getting a better understanding of APIs, and so forth. So it does introduce some other problems, but the key ones is that you save time net by automating most of the crap problems out.
Thank you so much, Philip, for your time. That great presentation. I'd like to thank everyone who provided questions as well. That concludes our first session, and we will shortly be having a 15-minute break. You will see a Zoom poll pop up on your screen to capture feedback any moment now. There we are. Your feedback is really valuable for us, so please do fill it out. Session recordings and slides will be available on the conference program page, so you can go back and have a look at your leisure. I would like to invite you to join the APNIC 50 social area. We mentioned it earlier on. Throughout the conference, there'll be lots of interesting activities there, including a trivia event this afternoon and meet the speaker sessions. More information can be found, as always, on the conference website. And finally, don't forget to share your photos on Facebook and Twitter using the APNIC 50 hashtag. There are already some brilliant ones up there. Thank you so much, and welcome to APNIC 50. Thank you.